Hi, this is your revision rundown for the Rules of Surds and Rationalizing Surds for the Edexcel IGCSE 9-1 Further Pure Maths course. Firstly, we need to know that a surd is the square root of a prime number. This will come in useful when we're asked to simplify surds. There are two key rules we need to know when manipulating surds. The first is the square root of a times b equals the square root of a times the square root of b. In this question, we're asked to simplify the square root of 12, and we have to do so using this rule above here. In order to convert the square root of 12 in the form square root of a times b, we need to break down 12 into two factors, one of which is a square number. We can do this by breaking down 12 into 4 times 3, therefore leaving us with the square root of 4 times 3. Using the rule above, we know that this can actually be written as the square root of 4 times the square root of 3. We know that the square root of 4 equals 2. The square root of 3, however, cannot be broken down further as 3 is a prime number. Therefore, we can simplify the square root of 12 as 2 times the square root of 3. The next rule we need to know is the square root of a over b equals the square root of a over the square root of b. In this question, we're asked to simplify the square root of 44 over the square root of 11. Using the rule above, we can rewrite this as the square root of 44 divided by 11. We know that 44 divided by 11 simply equals 4 over 1, which we can get by dividing the numerator and the denominator both by 11, and this simply equals 4. Therefore, we know that the square root of 44 over 11 equals the square root of 4, which we can simplify to 2. Therefore, the square root of 44 over the square root of 11 equals 2. The next thing you need to know in this section is how to rationalize the denominator of a fraction. This is when you make sure that the denominator of a fraction does not have any surds or square roots. You can rationalize the denominator of 1 over the square root of a by multiplying the top and bottom by the square root of a. Essentially what you're doing here is, in this fraction, we have a square root in the denominator. We want to get rid of that, so we multiply the top and bottom both by the square root of a. This leaves us with a numerator of the square root of a and the denominator of a. In this question, we have to rationalize the denominator of 12 over the square root of 2. Similarly to above, we multiply the top and bottom by the denominator. 12 times the square root of 2 will stay as it is. However, the denominator will leave us with 2. Now we can just simplify by dividing 12 by 2, which leaves us with 6 times the square root of 2. Now we will practice an exam question. In this question it says, simplify the square root of 32 plus the square root of 18, giving your answer in the form p times the square root of 2, where p is an integer, for 2 marks. What you need to do is, first, you need to break down the square root of 32 and the square root of 18 using this rule that we've learned here. However, the key to this question is here we can see that the answer wants us to give it in the form p times the square root of 2. What this means is when we break down the square root of 32 and the square root of 18, one of the factors needs to be 2. Firstly, we'll break down 32 into the square root of 16 times 2, which we can rewrite as the square root of 16 times the square root of 2, using this rule we learned earlier. Similarly, we will break down the square root of 18 into the square root of 9 times 2, which equals the square root of 9 times the square root of 2. Now, we know that the square root of 16 equals 4, and the square root of 9 equals 3. So we can rewrite this as the square root of 13 equals 4 times the square root of 2, and the square root of 18 equals 3 times the square root of 2. Now, when we rewrite the square root of 32 plus the square root of 18, we can rewrite it as 4 times the square root of 2 plus 3 times the square root of 2. And this simply gives us 7 times square root of 2.